thanks again for joining us once more for yet another study group. Hopefully everyone is enjoying these. Now, I'm going to warn everyone that the format is changing a bit this time. This is actually the second time, maybe the third time, that I will get to hear Hart's presentation. I saw it live once and went, I have to get this for all the JV and Linux Academy people because they're going to love it. However, I will state that though we like to stick to the 100 level, when it comes to 100 level tech, this is a bit more advanced because it's really delving into using Kubernetes, not just deploying it, but actually setting up and configuring your security for it. So in order to make it a little bit easier, what I hopefully will be easier, I had Hart come in and present it, and I listened to it and I took notes. Those notes are being shared on the Jupiter Broadcasting GitHub. I'll post those in Slack or in IRC in just a bit, so you can kind of follow along and expand out on those notes. We also pre-recorded it, and we have broken it up to about 6 different segments. We'll play a segment, pause, answer the questions that you have, set up what you need to know for the next segment, and continue on. So please be active and write all the questions that you want into Slack. Hart, welcome. Thank you for joining us today.
Thanks for having me. I'm happy to be here.
I think I just kind of bulldoze through that. Is there anything else you think that anybody needs to be aware of before we get started?
So just as a heads up, this isn't going to be, like you said, it's not a 100 level, and that's true. This isn't going to teach you really how to run Kubernetes or install Kubernetes. This is really like you have cluster, and now you need to secure it. So there is that for level setting anyway.
Before we get started on the content, though, would you mind introducing yourself to, I guess, the rest of the class?
Oh, yeah. Who am I, right? So my name is Hart Hoover. I am a cloud-native architect at VMware, formerly Heptio and CoreOS. What does that mean, cloud-native architect? It means I help customers with VMware's Essential PKS, which is the open-source modular Kubernetes offering from VMware.
All right. And you have to do the question that I ask everyone before we kick it off, and that's it's okay to be news story. How did you get started with Kubernetes?
Oh, man. How did I get started with Kubernetes? So I got started with Kubernetes at CoreOS. I was working at Cisco before CoreOS, working on OpenStack efforts, and saw Kubernetes as kind of the future. So I decided to go apply and luckily got the job at CoreOS. And got trained up immediately. So, oh my gosh, I got brain dumped on by a lot of very, very, very smart people. So I was very, very blessed to have that opportunity. And it's just been kind of riding that wave since then. But it helps to have people around that are smarter than you.
You know, I think that has been the basis for my whole career. So I'm okay with that. I've always been told if you're the smartest one in the room, find a new room.
Yeah, very true.
All right.
Luckily, I don't have to find a new room yet either.
All right, Wes. Well, if we have the first section of the video, I think we can kick this off. So, Hart, before we get started with your presentation, would you mind telling us a little bit about what you're going to be covering today?
Sure. So I'll be talking about how to secure your Kubernetes cluster, assuming you have a Kubernetes cluster. So this talk is for those people who have Kubernetes and want to implement some security features of the platform. You know, how do I get started with it in a secure way and operate it effectively?
Now, I want to remind everybody that you are happy to answer questions. So as he's going through the material, if you have questions, make sure to get them into that embedded chat, the IRC chat, YouTube, wherever you're watching it. And I'm going to try my best not to interrupt too much during the presentation. So we'll kind of come back in the end and start addressing them. All right, if you're ready, let's go ahead and kick this off.
Sure. So the title of this talk is Don't Be Famous, Securing a Kubernetes Cluster. And in 2019, everybody, it seems, wants to be famous these days, whether it's like Instagram famous or Twitch famous or YouTube famous. But in this case, your company does not want to be famous because that means that you've been hacked in some terrible way. And and the cost of being famous is not great for the United States. We have the highest total average cost of a data breach in the world, according to Forbes. It's not cheap to get hacked, so you don't want to be hacked. I think this may have something to do with like Equifax or some other companies in there, but mainly, don't be hacked. It's going to cost you a ton of money. It's not going to be great for your bottom line in general. So some famous breaches related to Kubernetes recently, as reported by Ars Technica, Tesla had a breach where their Kubernetes dashboard was not password protected, and they were running pods in an insecure way. So access credentials were exposed. They got access to the rest of Tesla's AWS environment, and things were not great. Another famous hack was against Shopify, in which the hackers actually took control of the entire Kubernetes cluster on Google, which is not awesome. They got that through a Google Service Account Token and a Kubernetes environment variable. Not great. So these are some examples of famous Kubernetes hacks that you don't want to be, right? So let's talk through some steps and like some things you can do to ensure that your Kubernetes cluster is secure just from a baseline thing. None of these are going to require any kind of like paid options. Now, there are a lot of paid security options out there to help you if you want to, consume those. But for the most part, these are things you can do with Kubernetes that just come out of the box, right? So first, let's talk about quote unquote legacy security. Now, what do I mean by that? Things that with regards to security that everyone already always should be thinking about, right? Securing physical access to your machines, making sure your network has a good perimeter, it's firewalled off properly, making sure your machines, your nodes are up to date, and that your workloads are isolated from each other. Now, what I mean by workload isolation, that could be development or staging or production, like the stage in which a certain workload is operating in that model, or it could be, this production system needs to be separate from that production system, and that's okay too. But these things are important no matter what you're running, and Kubernetes is no exception. And even some of this will be on you. Let's say if you're running in a VMware environment in your own data center, and some of this might be on your infrastructure service provider, such as AWS or Azure or Google Compute. For example, you are not going to be able to get into AWS's data center, and that's okay for everybody. So that physical access is controlled.
All right. Now it's time for some questions.
All right. So one of the first questions that I have, and I think this might have cut out a little bit sooner than we thought, but we'll kind of get back to it with updating machines, Hart. Now, just in security in general, this seems to be the biggest point of vulnerability, where we see that people haven't patched systems because they've either forgotten about them or, are afraid it's going to break an application. In your experience, have you seen this to be true when it comes to the Kubernetes world as well?
So, that's a good question. So I've seen applications that are updated constantly by developers. Now, when it comes to the platform itself, we're going to talk about that in a little bit. But if you are getting Kubernetes as a service, they handle the updates for you. If you're running your own Kubernetes, you can get releases from the community every few months. They have a release that is considered stable that you can get and apply to your nodes. And we'll talk about upgrading in a little bit in the presentation. But as far as applications go, with these companies that are operating Kubernetes, they tend to do multiple deploys, pretty often and keep their images up to date. Hopefully you're scanning your container images for vulnerabilities that are inside those images. But for nodes themselves, typically, people are turning over nodes so quickly that it's okay in a Kubernetes environment. But if not, I've seen just, cron jobs running to keep stuff up to date, or they have, once a week patching or something to keep nodes up to date, to be honest.
Now, you talked a little bit about, not to stick on the same subject, but I guess it's what I'm really interested in, is the vendor providers actually pushing through the updates. Now, is this something that, if I have a Kubernetes cluster, I have to opt into, or is it something that's automatically going to be given to me and I should, just, I guess, be careful of my code to make sure that those updates aren't going to be affecting my environment in a negative way?
So that would depend on what kind of Kubernetes cluster you are operating with or what kind of service you're consuming. So some, for example, like GKE or AWS's Elastic Kubernetes service, EKS, they do the control plane updates for you automatically, and then it's up to you to cycle through your worker nodes to take advantage of new updates. If you're doing it yourself or getting it or running it yourself, like through just either on EC2 or a vSphere environment, vendors will provide you as part of like a distro or signed binaries or something like that. They'll provide those to you, and then it's up to you. They'll help you with upgrading.
Okay,
but it's up to you to update.
Yeah, so I think we're going to go into, I'm be very interested in doing this live, is where this picks up at. So let's go ahead and kick off and see what the little next section is.
Another thing that you can do with Kubernetes is from the start, you get better security through your Kubernetes cluster architecture. So let's take a look at what a Kubernetes cluster looks like. Here's the crazy diagram from the Kubernetes blog. Basically, everywhere that you see a line on this document, whether it's pink, blue, green, orange, or whatever other color we have here, that can all be with TLS. And everything that can use TLS probably should use TLS. You want to use secure communication between cluster components. And a lot of this has come over the years that Kubernetes has been around. It started to become the default, which is always good. You'll see here also that in this example, etcd is running on a controller node or the master node in this diagram, and it does not run on the workload nodes. That is by design. Worker nodes should never have direct access to etcd for any reason in a Kubernetes cluster. All communications, as you'll see through that beautiful pink line, go through the API server, and then only the API server communicates via a certificate authentication to etcd. Even better, you can have etcd completely separate from your controllers and firewalled off, so only the controller nodes can talk to it. Etcd has a different, you'll get some benefits out of this anyway. It's better for security. Etcd has a different lifecycle management than the rest of Kubernetes, so you'll be better off there as well. So you can upgrade. It basically makes your controller nodes much more stateless if etcd is not running directly on them. So that's good too. Another way that you can secure Kubernetes is through upgrades. So if you have an iPhone or even an Android on certain mobile providers, you're used to constant app updates on your phone that happen all the time, overnight while you sleep, whenever. And then occasionally you'll get, a complete phone OS update. Again, unless you're on Android on certain mobile platforms, but whatever. Side note. The new hotness is definitely continuous delivery of the entire platform or immutable infrastructure. For constant updates, they're normal in 2019. Updates are just happening all the time to underlying software. Kubernetes itself has updates every few months. And you can choose your own adventure when you're upgrading Kubernetes. You can either upgrade the cluster that you have in place, which has a lower infrastructure cost. You're not replicating clusters between, you're not doing an N+1 entire cluster. But it is considered more, quote unquote, dangerous in that you're upgrading something that's running production, right? When you're upgrading in place, it's also the potential is to have a configuration drift between what you've committed to, say, your infrastructure automation, like Terraform or Ansible or whatever, and then what's actually running on your nodes. So you need to kind of watch out for that. And then finally, external access, if you upgrade in place, is easier. And what I mean by external access, I mean, let's be real, not everything in your entire company is going to run on Kubernetes. You're going to have some workloads on Kubernetes and some workloads elsewhere. This could be managed database services, authentication services, S3 or whatever, like all that stuff running outside of Kubernetes. And so controlling access to and from the cluster is what I mean here. If you're upgrading in place, nodes aren't changing, that external access is easier. You don't have to go upgrade security groups or whatever. If you're standing up a new cluster, the downside is you are doing an N+1, right? You have a higher infrastructure cost, at least for a time, while you're deploying a new cluster and then moving workloads over. However, it is less quote unquote dangerous because you have a new set of machines. It's not upgrading something that's in place running production. Although it is a better practice to have immutable infrastructure, in this case, an immutable cluster. So you treat the entire cluster as a deployable unit, and at upgrade time, you just deploy a new cluster, move stuff over. And then again, however, this makes external access to other services and other workloads a bit harder to work with. So there's your choose your own adventure. So when you're updating in place, typically, I've kind of zoomed out on your Kubernetes cluster here from the diagram we saw earlier. In this case, we've got 3 controllers and 4 worker nodes. You take a controller out of commission, out of the load balancer pool for API, and then replace the binaries, restart the services, and move on to the next one. Put it back in the pool, and just do kind of a rolling update process until your controllers are updated. And then workers, you can either replace those as you see fit, or you upgrade those in place too by doing the same thing. The real key to updating in place are these 2 commands, kubectl cordon and kubectl drain. Basically, cordon means, I'm marking these nodes as unschedulable. You cannot put things here. And then kubectl drain tells Kubernetes if there are workloads running on these nodes, get them off, move them somewhere else in the cluster. So these 2 commands will help you when you're updating a cluster in place. Another tool that's great for upgrade time is a tool called Velero. It used to be known as Arc when it was managed by Heptio, which was acquired by VMware last year. It's now called Velero, and what it does is it does backups and restores for Kubernetes objects. So it runs a service in the cluster that manages backups for you. And what you can do also with Velero is have the same agent running in 2 clusters and then basically use it to migrate your workloads. Really helpful when you're at upgrade time, or just generally for backups in general. It's good stuff, but at upgrade time, it's awesome because it will help you with that disaster recovery piece of moving workloads from one cluster to another when it's time to update. And, one more thing I wanted to call out, like I work for VMware, I'm biased, but, it's okay to use a Kubernetes service that's out there. I mean, we have one, it's called Cloud PKS, but you can use Amazon's EKS or Google's GKE, AKS if you're on Azure, and there are a myriad others. DigitalOcean has one, like everyone has one, right? So, if you're using a Kubernetes service, it means that the provider handles upgrades for you, and it makes it a little easier. And, I want to call out that if you can consume Kubernetes as a service, like go for it. It's a lot easier to work with. You won't have to even really worry about this because the provider handles it for you. And it just kind of solves a lot of problems. So if I want to give you permission, if you're here listening, like, well, I've got to run everything on premise, well, then okay, we've got some tools to help you with that too. But if you are in a full cloud environment, like go ahead and consume a Kubernetes service. Totally fine. Totally fine.
And now, time for further questions.
Thanks for the transition there, Wes. So we kind of jumped into it, Hart, but I might have a few people here who perhaps are not Kubernetes ninjas yet. So could you go a little bit into etcd, what it is, what it does, and why we're cordoning it off from the rest of our environment?
Sure. So etcd is the state in Kubernetes. It's a database based on what's called the Raft protocol. And it is a clustered NoSQL database, key value store that acts as basically the knowledge of Kubernetes, of what's going on in your cluster. Everything else in Kubernetes is considered stateless. So the reason you keep it separate and firewalled off from your cluster, at least a good idea, is to have just better security, because etcd is like the most important part of your cluster. You can replace almost everything else in the cluster, very, very easily. etcd is a little bit more complicated to deal with if you are bringing nodes up and down. That's why it's also a good idea to have it separate from your control plane, so that you can, again, like I said in the presentation, manage the lifecycle of those things differently. It makes your controller nodes stateless. So there is a fantastic animation that I'll drop in the chat on the Raft protocol and how etcd actually works. It's amazing. But the way etcd works is, let's say you have a 3-node cluster, and you talk to one node. An API server says, hey, I need to run a pod, and it records in etcd where that pod lives. etcd will take that request and make sure it is written to 2 nodes before it gives you like an okay response. So it's very cool. I need to find that animation thing for you, though.
Yeah,
it's really nice. I'll
get it from you, and we'll throw it in those GitHub notes. We did have a question come into the IRC channel, which is an interesting one, and it's, should we really care that we have K8s on premise? Is there a benefit to it outside of, or instead of using a third-party provider?
Sure. So you may want to take advantage of Kubernetes, but have regulatory requirements or something like that keeps you in a data center environment, in which case you can't use a Kubernetes service. You have to use an on-premise Kubernetes, but you want to take advantage of Kubernetes orchestration capabilities.
So I have 2 more questions before we go on. We did a lot of talking, or I guess you did a lot of talking about securing these connections. My guess is there's going to have to be some keys somewhere. How are keys stored to allow the decryption of this communication as it's occurring?
So each node in the cluster has a set of TLS keys, certs and key pair, that it'll use for authentication to the API server. And the controller nodes have a cluster CA and then several key pairs for proxying and talking to etcd. So etcd has its own set of certificates that it uses just for the API server to talk. But those live on the nodes themselves and are mounted into containers that are running as part of Kubernetes services. So like the API server will mount those TLS certs from the host directly.
And before we kick off to the next section, I guess I'm going to do a little bit of foreshadowing, because we are going to be talking about Kubernetes namespaces. But as a lot of our students and our viewers come from the Linux world, I want to make sure that we clarify that Linux namespaces, though they can contribute to Kubernetes namespaces, are not the same thing. So would you mind setting a little bit of foundational groundwork for Kubernetes namespaces for us?
Sure. So Kubernetes namespaces, all they are really is just a way to name things in Kubernetes and isolate them from each other. So you can have groups of things that are together. And that's really kind of all they are. They act as a boundary that we'll talk about in a little bit. But for the most part, they're just like a grouping of named things.
All right, Wes, we can kick off the next section, and then we'll come back with some more questions on the namespaces.
So moving on to another security topic, role-based access control. So,
please use Kubernetes RBAC, but have common sense and tie it to what you already have. Every company has some type of authentication system. So, it's okay to link those systems to Kubernetes to help you manage permissions. So some core concepts about role-based access control. It's well-defined, standard concepts. You find it everywhere. You have a subject, role, and assignment. So a subject could be a person, a service account, or a group. A role means what they are allowed to do, set of permissions. And then assignments telling the system this subject can do these roles, right? Has these permissions. So in Kubernetes, you'll have roles and cluster roles for role-based access control. A role contains rules that represent a set of permissions. These permissions are additive, means there's no explicit deny rule in them. Like you are giving permission, and if you don't grant it, it's assumed that they don't have it, right? And roles are defined at the Kubernetes namespace level. Whereas a cluster role are just like roles, except it's cluster-wide. So you have access to cluster-wide entities like nodes, custom resource definitions, namespace resources, but across all namespaces and non-resource endpoints. You can also combine these things. So you can define cluster roles like together in combination. So some examples. A role looks like this. Notice it has a namespace attached to it. In this case, this is allowing you to read pods in a namespace. So in this case, the default namespace. So the rules here are setting up a role where you're saying for all pods, this role allows you to get, watch, and list pods. Whereas the cluster role, this is a secret reader role. Notice there is no namespace attached because, again, it is cluster-wide. So while secrets are namespaced resources, if this cluster role is applied to an agent or user or group, they will have access to read secrets in any namespace. What's great about Kubernetes is that for role-based access control, there are cluster roles that are already included with the system that allow you to kind of have baseline permissions to make sense, right? So the view cluster role is basically read-only. Edit is read-write. Admin is admin over a namespace. Everything pretty much except quotas and like some special policy stuff that we'll get into later. And then, so the bottom three, admin, edit, and view, are all namespace based, whereas cluster admin is, cluster wide, root, basically. You can do anything, anywhere, God mode for Kubernetes. But you can use these things to have some common sense roles for groups in your organization. So now that we know what kind of roles and cluster roles are, how do we grant them to users? And in this case, you use role bindings and cluster role bindings. So a role binding binds that permission at a namespace level, and then cluster role bindings bind that at a cluster level. So you're basically applying a role or a cluster role to a user or group at either the namespace level or cluster level. Hopefully this all makes sense. How you doing, Elle? You still with me?
Doing good. So far I'm following. I've got my pen and paper and we're good.
Just checking. Okay, so some role binding and cluster role binding example here. So again, notice the role binding has a namespace. This is the dev namespace, whereas the cluster role binding doesn't have a namespace because it's cluster wide. So in this case, we are binding, in the role bindings example, we are binding the cluster role secret reader, but we're namespacing it only to the dev namespace for user Jane. So in this case,
the user Jane is going to be able to read secrets, but only in the dev namespace, not everywhere. Whereas in the cluster role binding example, we have a group here of managers that are able to read secrets no matter what namespace they're looking at. So cluster wide. So some things with Kubernetes RBAC that you should be aware of. The challenge, is if you're too granular with your roles across multiple namespaces or multiple clusters, even like if you have a dev cluster, staging cluster, production cluster, like if you're getting too granular with your roles, I call this role sprawl. Basically, you have too much to manage. Like you can use cluster roles and use them with role bindings just to simplify, your role management. You don't want to have like a billion roles for every possible permutation of permission. Like make it easier on yourself if you're running Kubernetes to use like, just some basic common sense cluster roles and then use role bindings for that user. So, and another thing you can do is simplify this whole process by using groups. You can tie Kubernetes groups to Active Directory groups, for example, using tools out there to help, get people on board, get users plugged in with groups through like Dex or Gangway, for example, if you're looking for something to Google. So again, like super important, use role-based access control that makes sense and don't do role sprawl stuff. So for example, some examples, if you have a developer, like just give them that admin cluster role, just give it to them, but over a single namespace. So this namespace is yours, or one or more namespaces depending on what's going on. But like you have admin over this namespace, you can do whatever you want within this namespace. If you have a non-technical manager that just kind of wants to keep an eye on stuff, you can give them the view cluster role that it's just read-only to a namespace or the entire cluster, so they can see what's going on without actually like breaking stuff. And then finally, if you have a cluster admin team, which I assume I'm probably talking to today, you have a cluster admin role here built in, like just make use of it, give that permission to the group that you're in. It's already built in, like just use it. And this will save you a lot of headaches as your Kubernetes deployment or deployments grow in size and scope.
So one of the things that I am seeing in the chat room are people kind of talking about their current configurations. And I know as Linux users, we all have, that story about permissions and what we found on a box, the 777 story. And I was wondering, Hart, do you have any stories of just RBAC configurations that have made you go, why? What is the story behind this?
Oh, every developer getting cluster administrator, obviously. So yeah, I've been to several companies that I will not name here that start out that way. That start out with, all people, they're all our company, they're all our employees. We totally trust them. Everything's cool, and they just get that cluster admin kubeconfig that's passed around, and we typically spend some time unwinding that and kind of back it up and be like, okay, well, I talk about role sprawl and stuff, but you need some roles. So that's like the worst case I've seen. Best case is what I kind of described, where it's generally developers get access to the namespace, or even better, there's a service account that's used that has admin to a namespace, and then only like a CD tool like Jenkins or something has access to that, and developers push to Git. And that's a much more secure workflow, and that credentials aren't passed around, and it all flows through one system, things like that. Like think about as small a blast radius as possible.
One of the topics that we're going to discuss, I believe it's the next topic, will be policies. And I'm wondering, do you find that Kubernetes administrators really focus on policy more than they do on the actual permissions for their RBAC environment, or for their environment when it comes to RBAC?
It's actually the other way, and I think it's because RBAC has been around for longer than these policies have in Kubernetes, and so knowledge of them has already kind of been disseminated to, the community at large or users of Kubernetes. So whereas network policies and pod security policies are newer, and so knowledge hasn't been spread as far. But when companies find out about network policy and pod security policy, they get really excited, especially if they're into multi-tenancy in clusters.
So when we kick off the next section, I'll be pushing a GitHub repo that you're going to talk about in the next section. But one thing that you do mention is how everyone starts researching policies by just reading blog posts. And I was wondering that before we kick this off, can you give someone advice if they listen to everything you have to say and they want to go read up more, but get practical examples instead of these blog post examples? What would you recommend that they look for?
Oh, man. So I say blog post example, but I'm going to recommend a blog post. So I have a couple of coworkers that are amazing. And one of them is Josh Rosso, who gave a talk on KubeCon about like day 2 operations. And he has some fantastic blog posts about Calico and pod security policies in general that are worth reading. So I will drop that link into IRC, and bam, there it is. So check out, honestly, there are some folks on Twitter to follow. I can drop some links in chat as well. But yeah, you kind of have to hunt for them. You're not going to find them in just real deep practical things on Google or something. I mean, you've really got to kind of hunt for them. And good place to start is just getting involved in the Kubernetes community and find the people that know what they're talking about and follow everything that they say, for lack of a better word.
I can get those added to our notes as well. And Wes, if we can kick it off, we can come back and see what questions people have.
So, 2 important policies, and policies here is in quotes because even though they're both called policy, they kind of act different. But 2 policies that you need to be aware of: network policy and pod security policy. So network policy is basically firewalls for pods, security groups for pods in Kubernetes. And something important to note, with no policies defined in your cluster, the default is allow all anywhere, which is fine if you are, my favorite example is if you are all one company and you don't really care about multi-tenancy, it's okay. I have a dev team and a marketing team, but we're all Coca-Cola. Everything is cool. If you are on a provider and a Kubernetes service and you work for Coca-Cola and you're sharing a cluster with Pepsi, you definitely want to have network policies in place. Because with no policies defined, the default is allow all throughout the cluster. So another thing to note is when you first apply a network policy, any network policy, that pod that it's selecting will flip from allow all to deny all except for what's allowed by that policy. So the first time you give it a policy of any kind, the pod will flip to deny all except for what you've said, you can talk to me. Another thing is to really call out here, network policy is it's an API in Kubernetes, but it's implemented by the network plugin you've chosen to use, whether that's Flannel, Calico, Weave, etc. So if your network plugin, your CNI plugin doesn't support network policy, it means nothing's going on there. The API server will say, yeah, I have network policies, everything's cool, but your network plugin won't actually do anything. So very important to note, make sure the network plugin that you've chosen supports network policies. And most of them do today, but that wasn't always the case. So just double check. It's always good to double check in security, especially. So let's look at an example of a network policy, again, kind of firewall for pod or security group for pod in Kubernetes. What this policy does is deny traffic from pods outside of the default namespace. So everything in the default namespace, in this case, we have 2 pods with labels app web and app equals DB running in the default namespace. Basically, what we have here on the left is a pod selector, and network policy works by matching labels on pods. And so in this namespace default, this is basically saying ingress from anywhere else, like, we're blocking them all, like match none. So this will block everything outside of the default namespace, but anything in the default namespace can talk to each other. I'm going to show you one more example, but I really want to call out this repository that is linked on this slide, github.com/AhmetB. Kubernetes network policy recipes has a lot more that I'm going to show you, and they're all fantastic and easily deployed to your cluster. So definitely worth a look. I'll leave it up there for 1, 2, 3. Okay. Another example here is, I have my Kubernetes cluster, but I want to allow external traffic to my web pod, but nowhere else. So here, again, I'm matching my labels to select pods that I want to allow. So web, and then ingress from, and it's an empty set. So, it matches everything only for app web. So this will exclude traffic to any other pods running in that cluster or in that namespace, and only allow it to talk to web-based, web-labeled pods, excuse me. So moving on to the other policy, pod security policy. What we need to know here is that while network policy is its own API object that you create via namespaces, pod security policy runs on the cluster, and it's an admission controller. So it is configured with the API server, and it works when pods are created. They're evaluated against any pod security policies that exist, and then it's determined, can this pod run in my cluster or not? So is it admitted to my cluster or not? Pod security policies give cluster administrators a ridiculous amount of options and power over what kind of workloads can run in a cluster. You can specify crazy amounts of things. It's like, I only want this namespace to be able to run volumes with this storage class and this type, or I want everything to run not privileged or not as root. I want to run with this SE Linux or AppArmor profile, like all sorts of things. Super detailed what you can do here. Refer to the Kubernetes documentation for pod security policy on all of your options. I'm going to cover some, but not all of them, because I can't fit it all on a slide. It's too much. I've tried before. It doesn't work. So go take a look at the Kubernetes documentation for pod security policy to see all the options. But what I'm going to show you here is some real world stuff, real world scenarios in which pod security policies are working. Also, another thing you need to know about pod security policies is that they're linked to RBAC rules. So rule-based access control in Kubernetes is setting what policies users have access to use. So not all users will need all policies. Obviously, that's kind of why they exist. So for example, you can have privileged users that can run privileged workloads if you wanted, and everyone else runs a default policy that limits those, right? So the way Kubernetes kind of attacks that is through the default RBAC process. So one thing to know for sure is that if you enable the pod security policy admission controller without any policies in place on a running cluster, bad things will happen. So if you enable the admission controller, it has, without any policies, it has no policies to evaluate running pods against what should be running in the cluster, and therefore it won't allow anything to run in the cluster. So you can submit pod security policies to Kubernetes API before enabling the admission controller as a way to get around this, which I highly recommend you do. Although it's kind of funky because, if you're trying to implement this on a running cluster, you need to kind of do weird things where you submit the policy, then add the controller to the API server and restart the API server. It's kind of involved, but worth it in the long run, I promise. So let's look at a typical pod security policy blog post setup. And why I call it the blog post setup is because this is what you'll see when you look up pod security policies and you find blogs on the topic. You'll typically see these two policies, a permissive and a restricted. And even the Kubernetes documentation has these two as examples, like a permissive and a restricted policy. This is not like real world scenario, but it's a good way to see an example of these in action, where a permissive policy basically allows you to do anything you want. And then the restricted policy allows you to do nothing, no privileged runtime, no run as root, no volumes, no host network, and no ports. If you tried to do this in a real world Kubernetes cluster, no one will use your platform because they won't be able to run anything. So, or they'll just ask for, can I have the permissive policy, so I can run a workload of any kind. So the better setup looks more like this, where you have a default policy that's pretty restrictive for user workloads. So you don't get privileged access. You can't run as root in your containers. You don't have access to the host network, and you only have access to certain volume types. So what is missing here? Host path volumes. You may have, in this case, like a SC Linux or AppArmor profile happening here in this default policy. So then you move on to a policy for things in kube systems namespace, or kube system. These are Kubernetes system components. They're going to need a less restrictive pod security policy. They just are by definition. They need access to the host network so they can have Kubernetes system components running, like the API server. Some of them are going to need host path because they need to be able to read certificates that are present on the host, things like that, right? So in this case, you may run, if you're doing log aggregation on a cluster, you may want to use something like this kube system policy. And finally, networking components. So they're going to need the most open, least restricted policy that's out there. They're going to need to be a privileged container. They're going to need to run as root. They're going to need obviously access to your host network, things like that. But notice what's happening here is that the networking policy is only going to apply to two things in your entire cluster, whereas the default is much more restrictive and doesn't allow access to a lot of things, and that's okay. Most workloads in a cluster don't need root access, right, to the cluster. Totally makes sense.
Now, I know that we're going to be pushing on time, but there is a question that came in through IRC that I want to address because it's the question that I get every single time that I talk about containers. So, Hart, databases in containers, bad idea, good idea? What was your final consensus?
So for me, I think it's fine. It's better to have more horizontally scalable databases. So think the NoSQL type database or etcd you can run on top of Kubernetes. It's fine to run more traditional databases like MySQL on Kubernetes. There are things called operators that are out there that can help you run these stateful workloads on Kubernetes. There are stateful sets in Kubernetes. But what it's going to require is, most likely, it will require you to use an operator style workload where you not only have the container running in your cluster, but you also have some type of logic around that container, and whether that's implemented through init containers or pre-stop hooks or things like that, or even custom controllers through custom resources in Kubernetes, to have logic in there that determines what happens when a pod is created or destroyed as part of a database setup, right? So you're not just going to have one pod running MySQL in your cluster, because that would give you no resiliency. And if it went down for any reason, you'd be totally down and there'd be problems. So you're going to have multiple pods in some kind of concert. So to do that, you're going to need some type of logic built into that workload to determine, like, okay, this pod went away or is going away. What happens to my database? Does it have some kind of like graceful, this node left. Oh, well, like this node is joining now. Okay, that's cool. Like you need that logic built in to run a distributed system, a database on a distributed system like Kubernetes.
I think
that's my answer.
I think that's a great point, because I feel that when I talk to people about databases and containers, they want to treat it like a monolithic app. Like I just have a database that's running in the background that's very similar to what I would do on an on-prem server. It's kind of frustrating trying to explain to them the amount of work and I'm not sure if I can get the right words out, but the amount of planning that needs to go in to be able to do this correctly in this type of architecture. So I know that we're going to be talking about logging, which kind of plays into this. I will say that we're kind of pushing and skipping a few questions because we are running a little bit short on time, but we will plug Hart's Twitter at the end of this, and I know that he is very receptive to questions. So Wes, if we can go ahead and push on to auditing now.
Last but not least, in a Kubernetes cluster, audit everything, right? So Kubernetes has audit capability. The API server logs all requests for auditing. So anything in cluster or anything that users are doing. Audit events can be managed by policy. It can get super granular on it if you want. On even a per resource basis. So I want to see everything that happens to secrets in my cluster, everything. Or you can say, I really want to watch what Ell's doing with my Kubernetes cluster, audit everything that user is doing. Audit events are written to disk on the controller nodes in a log file, or they can be sent to an external webhook if you want. What you seriously need to know about audit logs is because there's a lot of stuff talking to the API server in Kubernetes. It can be super noisy. So if you are storing log data from your audit log in something like Elasticsearch or a paid service, you be prepared for that billing statement because it's going to be very big. So the audit policy is super important because you only want to log what you need with regards to the audit log. Stages of an API request. So these are things that you can audit in your audit policy. Each API server request has these stages in it. So request received, I got the request. I am responding in the response started phase. The response complete, I have responded. And then panic at the Kubernetes, everything has gone wrong and something happened, right? Panic has occurred. For audit logging, so when these things happen, how do I want to log them? So you can really specify a none, which is, I don't care about this at all, don't log it. Most of the time, and before 1.8, Kubernetes was logging everything at the metadata level, which is the user, the timestamp, what they were requesting, the verb, like get, post, patch, etc., but not the request or response body. So that, if you want that plus request or request response, you can get those in the latter two stage log levels. So you can say I want a ton of data about the request and response, or I don't want any, or I want limited data about each request. And that'll be different for everyone. So this is like the most basic audit policy you can have. It's basically auditing everything at the metadata level, which is a lot of stuff. Again, don't do this. But I just wanted to show you what it looks like in all. So you can say, I want to log everything at the metadata level, except I don't want any API request received stage. I don't want that stage in the request. Just throw that away. There is an example audit policy in the Kubernetes documentation that Google uses on their managed Kubernetes service, GKE. At least that gives you a better starting point than this small little YAML file. it's much more detailed and gives you a lot of options there. And finally, like once you have an audit log, you can, graph it. You can monitor it and follow it and see what's going on. There are Grafana dashboards out there that can, show you, for example, the FluentD user service account was requesting access to my etcd pod and the user agent and what verb they were doing. And then, graph it and such. So this data is super cool. Grafana dashboards out there exist for this. Like, it's totally worth investing some time into to get some visibility into what's actually happening in your cluster. And if something horrible goes wrong, you can find out like what happened, right? Who made the request that broke my system, or what made the request that broke my system. So overall, what did we learn today? We learned that it's super important to secure Kubernetes, and there's a lot of ways to do it right out of the box without any paid stuff. Basically, in summary, keep everything up to date all the time, like not only your workloads, but also the platform itself. Use role-based access control, make use of it. It's already built in. Tie it to groups that you already have in systems that you already have. Like there are tools out there like Dex that can help you get plugged in. I want to hook up my Kubernetes to Active Directory and make that work. Finally, set policies that make sense. So don't get crazy with role sprawl. Don't get crazy with pod security policy and network policy. Make it easy on yourself. There are some basic policies that you can take advantage of that will cover most, 80, 90% of your use cases, and it's probably fine. But if it doesn't go fine, there's always the audit log, right? Audit if everything goes wrong. So you have something to look at and find out what happened, and you can prevent it in the future. Don't be famous. Thank you very much.
Okay, so one of the questions that came in through IRC was talking about projects that help you with auditing, different projects that are either cloud native projects or perhaps proprietary projects. I was wondering if you have a favorite, an opinion on, what somebody could get started with.
Oh, I have so many opinions, but so honestly, I love the Elasticstack. It works with Kubernetes. There's, Elasticsearch. When I say Elasticstack, I mean Elasticsearch, FileBeat, and Kibana. For Kubernetes, those work fantastic out of the box with Kubernetes. Someone asked in IRC about FluentBit. I also love FluentBit. I like running FluentBit as a daemon set on my Kubernetes nodes. And then if I need to do log transformation for a customer, I will have a FluentD deployment. Sometimes you'll see FluentD deployed as a daemon set, but I think it's a bit beefy for a log aggregator. It's compared to FluentBit, which is much more lightweight. So I like FluentBit a lot as the log collector, and then FluentD in a smaller deployment that just does transformation if needed before forwarding it on somewhere else. FluentBit and FluentD together are great. FluentD is really nice because I've had a customer where they've sent all of their app logs to an Elasticsearch cluster, and then sent their audit logs to S3 and just dropped them in there to have them for backup, but not really for analysis. So there's that. There's a lot of good tools out there, but those are my faves for logging.
Now, I know we covered a lot of stuff here today, and there were people who are going to be watching the recorded version of this because they couldn't join us today. What's the best way for them to reach out to you to be able to perhaps get questions answered, or if they just kind of want to talk your ear off about something that you presented on?
Oh, well, send me a letter in the mail. I'm just kidding. No one sends me letters anymore. It's kind of sad. Twitter is the best place, of course. I'm on Twitter at H Hoover, HHOOVER, like the vacuum with an extra H. Reach out to me on Twitter if you come across something. Now, if you come across this in 6 months and you're like, you're totally wrong, you kind of, got to give me the benefit of the doubt. Open source moves fast.
It's what I tell everybody. If you find something that's more than 6 months old, it's probably out of date when it comes to containers. So thank you everyone for staying up late and joining us tonight. Friendly reminder that we do have a few more study groups planned for the month of June. The next one will be Back to Basics, Linux Permissions 101, continuing our security journey. And we would love to see all of you there. Thank you, Hart, for joining me today. And thank you, Wes, for playing DJ for today.
Thank you very much. I had a good time.
Thanks for teaching us so much. I know that was super helpful for me. I'm sure it was for many others out there, too.
Thanks, guys. Good night.
Good night.